Welcome to Assignment 2 of Communication Principle under the guidance of Dr. Osman bin Ayub. Today, for our video, these are our members and the people who will guide you throughout. Faisal Khalid, Talha Sohail, Hyun Tung, Amma Nasir, and Ali Mahmood. Firstly, thank you for finishing and answering the questionnaire. This video hopefully will give you the necessary knowledge to finish the Ericsson Games Mission 3 successfully and easily.
Digitization. Digitization is the process of converting information to a digital format. You may have heard the term analog signal before. Analog signal is a continuous signal in which one time-varying quantity represents another time-based quantity. Ever watch something on the old-fashioned TVs with the antennas on top? The antennas are receiving analog signals. In fact, almost anything can be an analog signal. In digitization, those continuous signals get transformed into ones and zeros, also known as binary numbers. When you take a picture or scan a book, you've digitized light. When you send a voice message to a friend, you've digitized voice. The digital representation of signals are easier to reproduce, store, and secure. Digitization is not the same thing as digitalization. Pay careful attention to the colored letters. Digitalization is the use of digital technologies to change a business model and provide new revenue and value-producing opportunities. In short, digitalization is the process of becoming a digital business. So while it is related, it is not one and the same. Digital switch. A digital switch generates or passes digital signals through telephone exchanges. It is essentially a hardware device that handles and connects digital signals. It enables callers subscribed to a telephone company to talk to each other. In a digital switch, digital signals can have one of two states, 1 and 0. They cannot have multiple states because digital switches are not designed to handle that. Only an analog switch can do that. However, digital switches perform faster. While there are several types of digital switches, the main two are time switching and space switching. Time switching means that the signal is transferred from input to output within the same time interval, while space switching means that the signal can be transferred to output at a late or later time interval.
Welcome to the explanation of sampling theorem. Now, to understand and play this game, you will need to have a basic understanding of what the word sampling theorem is, what it signifies, who made it. To begin with, the textbook definition of sampling theorem states that a band-limited signal having no frequency components higher than a FM Hertz can be sampled if its sampling frequency is equal or greater than the Nyquist rate. Now I'll get back to Nyquist rate a little later. There are three types of sampling theorem: natural sampling, flat top sampling, and ideal sampling. In simple terms, sampling theorem is the minimum number of samples you need to reconstruct a signal based on the original signal so that you can convert it from analog to digital. To get a better understanding, let's move to bit depth. Now, the definition of bit depth is that the audio bit depth determines the number of possible amplitude values we can record for each sample. The most common audio bit in modern times is 16, 24, and 32. And for consumer ends, it is usually 16, and for professional, it is 24 bits. Now, how do you understand bit depth? To understand bit depth, you need to understand this graph. In the x-axis, it is time-based, and in the y-axis, it is amplitude-based. Bit depth is usually rounded. So say if your maximum amplitude is 6.8, we'd round it to an upper bound of 7. And since it's binary, it works into the power of n factor. So 1 is equal to 2, 2 is equal to 4. Now, if we go on to the sampling rate, it represents the change in amplitude over time. And to get a good sampling rate, you would need to have twice the frequency. So if you're working with 800, you would need to go to 1600 Hertz. In the modern era and modern times, the standard is 44 kilohertz. Now, moving on to Nyquist. Harry Nyquist is a Nobel laureate who essentially pioneered sampling rate and made it so that we can hear clear audio like right now. Nyquist's theorem states that the periodic simple signal must be sampled at more than twice the highest frequency of the component of the signal. In most basic terms, Nyquist's works states that an analog signal waveform can be converted into digital by sampling the analog signal at equal time intervals so that the more samples you take, the clearer the frequency comes.
And now, pulse code modulation, PCM. We already know that PCM is a method used to represent an analog signals in terms of digital words. As we can see here, it's have three steps: sampling, quantization, and encoding. First, sampling the analog signal, quantization of the amplitude of the sampled signal, and lastly, coding the quantized symbol into a digital signal. As you can see, we start with an analog signal, and we do the sampling, just like Ammar explained before, and then we do the quantization and encoding to get the digital output. Quantization. Quantization is the process of mapping the continuous infinite values to a similar set of discrete finite values. As you can see here, the blue line is the analog signal, and we have this red line, this discrete red line. This value is zeros and one that will give us a close signal to the analog signal. Of course, it's not going to be the same. It will have a bit of difference, and we will explain that a bit later. Quantization level is this blue line, as we can see in this horizontal lines, dotted lines. It's either a line, as you can see, or the binary bits here. Okay, so it's basically the values that we get here, which will determine the path of this line. Okay, we can get it from this formula, L equal to 2 power of n. For example, if we have n equal to 3, we'll get 8 levels, just like this graph, from 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 levels. Quantization error, which I just talked about, is also called quantization noise. Okay, quantization error is the difference between the analog signal, here for example, here, and the closest available digital value at each sampling instant. You see, this red line is the analog line, right? While these lines are the quantization lines. So some parts they don't cross, so we cannot get a value for them. So we need to do this step to get the actual value and have a better output or output signal. Lastly, line coding, a process carried out by a transmitter that converts data in the form of binary digits into a baseband digital signal that will represent the data on the transmission line. Just like we can see here in this example, we can see that it's a digital. We converted from a digital, from an analog signal to a digital 1 and 0 signal. Lastly, the consideration for a line coding format. First, transmission voltage and levels, duty cycles, bandwidth, synchronization, error detection, and error correction. Thank you.
Multiplexing. So what is multiplexing? Multiplexing refers to the combination of information carriers for transmission over a shared medium. The main objective of the system is to increase the capacity of a transmission channel. In the system shown, n lines share bandwidth of one link, where the multiplexer combines several signals into a single one, and the demultiplexer separates the stream back into its original components for transmission. Time division multiplexing is used for transmitting several message signals over a single communication channel by dividing the time frame into slots, one for each signal. There are two types, TDM with pulse amplitude modulation and TDM PCM. This is a communication system where the information signal is modulated using pulse amplitude modulation. The information is encoded in the amplitudes of signal pulses and transmitted using different time slots via time division multiplexing. Synchronization is a critical consideration in TDM because each pulse must be distributed to the correct output line at the appropriate time. The simplified system shown demonstrates the essential features of time division multiplexing. Several input signals are pre-filtered with a bank of low-pass filters and are sampled sequentially. The rotating sampling switch or the commutator at the transmitter extracts one sample per revolution. Hence, its output is a pulse amplitude modulated waveform that contains the individual samples periodically interleaved in time. A similarly rotatory switch at the receiving end, called a demodulator or a decommutator, separates the samples and distributes them to another bank of LPFs for reconstructions of the individual messages. Time multiplex PAM output is shown as here, with the F1 is a frequency of one message signal and F2 is the frequency of another message signal. The sampling rate depends on the bandwidth of the signals. The time multiplex PAM signal can be sent out on a line, baseband communications for example, or used to modulate a transmitter. Theoretically, the bandwidth occupied by a pulse is infinite. The advantages and disadvantages of TDM. Advantages of TDM PAM is that it has high reliability and efficient operation as the circuitry required is digital, relatively small interchannel crosstalk arising from nonlinearities in the amplifiers that handle signals in the transmitter and receiver. A major disadvantage of TDM PAM is that it has timing jitters.
So today I'm going to talk about TDM, especially about TDM BCM. So TDM is used in digital system, and there are two types of system. One is TDM EAM and TDM BCM. But today I'm going to talk more about BCM. And basically, TDM BCM system can also receive in the form of samples. However, the PAM sample needs to be changed to digital form by using quantizers, motor, or analog to digital converter after sample by the combinator before turning to the line. So, so how does the TM communication work? There are two standard in telephone system that CM, PCM, TM, such as that E line by AT&T in US and E line by CAPM in European countries, but in Malaysia we use the standard fixed CE. And so, as you can see, this is the first structure and determined European standard PCM and currently Malaysia currently using that. And so this is the time division multiplexer DMBC multiplexer process of pre-information. You can see here, you can see the computer is has the switch if we were just to select its symbol at that time. And the position of sample bit information signal in time domain. And this is the line inherited sub CBM telephone system. And so I'm going to talk about this. So we have the 30-volt channels and the signal sample E1 for the E1 line equals 32 channel are multiplex for the transmission. And then the output of mux 1 will go to the one of input of mux 2 and the E2 line. The and the E2 line will multi-leverage from the E3 line. And lastly, the 4 E3 line will multi-leverage from the E4 line, and the data rate is 139.264 Mbps. And why we need the TM needed, why TM needed in the same, so they can eliminate the distortion. So this is by the super and regenerate TM and output. This ensures that the received signal is free from distortions and noises. At the destination, the signal is handed in valid and demultiplied using a BCM receiver. So I hope that this will so you can understand how ADM and BCM work, and good luck with your game. Thank you.